So for question number 1, I had a number of people in here in scheduled help and over lunch who were debating about the way to do this question. And almost to the last person, they were doing it the long way, not the wrong way. Perfectly well arrived at the right answer, but it takes a lot longer to do than the way I would do this question. Okay? Is work being done in this question? Right? There's a force being exerted through a distance in this question. Agreed? Okay. So work is a change in mechanical energy, but in this case, only one kind of energy is changing. What is it? Kinetic. Okay? It mentions nothing about changes in height here, only speed. That means only the kinetic energy is changing, which means that force times distance equals 1/2 mvf squared minus 1/2 mvi squared. And since this person is a major league pitcher, how fast is the ball moving before he starts to pitch it? 0. Can I solve for D really fast? Because I know everything else in this question except for D. Okay, this is by far the fastest way to do it. Okay, finding the net force and then using the acceleration formula and all that, it's going to arrive at the right answer, but it's a lot more steps than this is. Okay, this is one step to arrive at the right answer. Okay, D will equal 1/2 times 3.350 times 56.3 squared divided by 2,000 newtons. Okay, so if we're doing that, okay, we have 0.5 times 0.350, what's 0.350, right? Yeah, times 56.3 squared divided by 2,000. All right, so he exerts the force over 0.28, because we only have 2 significant figures here, right? Nope, we have 3 significant figures here. So it'll be 0.277 meters. Okay, so I would say 1 mark for givens, 1 mark for identifying work as a change in energy, 1 mark for their manipulation / plugging in of the numbers, and 1 mark for 0.277 meters. The other way to do this. Okay, does anyone need that anymore? I'm going to erase it and do the other way here. All right, so the other way is that I know the force is 2,000 newtons. Okay, and I know the initial velocity is 0 meters per second. I know the final velocity is 56.3 meters per second. Okay, and I know the mass of the baseball, 0.350 kilograms. All right, the only force acting is this force, so it's by default the net force. Okay, so then I'm going to say that F net equals m times a, and I'm going to solve for the acceleration. All right, so once I have that, I'll go F net divided by m. So I'll have 2,000, okay, divided by 0.350, okay, which is a ridiculously large acceleration. That's what it is. Okay, we just have to go with that. And then, now that I know that's a 5714, okay, now I have acceleration VI and VF, okay? So now I can find D, but I'm going to have to use this formula, VF squared equals VI squared plus 2AD. The problem was most people who were doing this way weren't choosing that formula. They were doing another step to find the time and then using a formula that could get them the distance after that, okay? And that's kind of what using the forces leads to, okay, is that it leads to you using too many formulas, bringing in too many steps, okay, and ending up doing too much work. So now I have to manipulate this formula for D. So D will equal VF squared minus VI squared divided by 2A. All right, so I'll have 56.3 squared minus 0 squared divided by 2 times 5,714. Okay, that will give me the distance. It should end up being the same distance. It should still be 0.277. Right? Right? The same answer, but it's 3 steps instead of 1. Okay. I mean, it's perfectly acceptable to do it this way, but it's more steps. It's more chance to make a calculation error or a manipulation error. Okay, if we do it with work is force times, if we do it, sorry, with work energy theorem, okay, it tends to work a lot faster. All right, so we still have 0.277 meters as our distance. All right, so that one's out of 4 marks, regardless of which way they did it. So they'd get 1 mark for givens, 1 mark for calculating acceleration, 1 mark for this step, and 1 mark for the answer. Okay, everybody all right with that? Okay. All right, our second question, okay, is a law of conservation of energy question. So we went over this kind of question yesterday, and actually I took this off of an old Science 10 exam. So you've definitely done questions like this before. Okay, so I've got the roller coaster here at the top of the hill. Okay, the hill is 42 meters tall. It's moving at 3.2 meters per second. And then down here, it's moving at 21.5 meters per second. I am looking for the final height. If you got givens written down, give them a mark. In order to do this, I have to understand that the law of conservation of energy applies here. Okay, so that's going to mean EI equals EF, okay, EPI plus EKI equals EPF plus EKF. They have something along these lines, okay, that can be their second mark. We're going to expand out to this MGHI plus 1/2 MVI squared equals MGHF plus 1/2 MVF squared, okay? And then we're going to manipulate to find the final height, right? So I'm going to cancel off the m's, which I have to do because it didn't give you the mass, okay? This was probably the one that screwed the kids up that I was telling you about yesterday, okay? So now I'm going to manipulate, and I'm going to bring the 1/2 of VF squared over to here. So I'm going to have GHI plus 1/2 VI squared minus 1/2 of VF squared, okay, equals GHF. I'm going to divide both sides by G. That'll leave me with HF. Okay, so give them a mark if they've got something like that written down. That's 3 marks. Okay, and we got to plug in our numbers. So 9.81 times 42, okay, plus 1/2 times 3.5 squared minus 1/2 times 21.5 squared divided by 9.81 will give me my final height. 1 mark for that. Okay, our final height Oh, 9.1. Good eye. Thanks for not letting me get through the whole thing. 3.5 squared minus 0.5 times 21.5 squared divided by 9.81. Okay, so here it is only going to be 19 meters off the ground because we only have 2 significant figures in that answer. Okay, so our final height is 19 meters, 5th and final mark. Questions on number 2? Okay, give it back to the person, let them see their mark. Then come up here, put them on top of the Chromebook cart, and grab a Chromebook.